Hello everyone and welcome to Excited Nuclei channel. So today we are going to see about our new project and that is going to be our we can say JSON base database, or you can say that we are trying to replicate a famous unstructured database, that is you can say MongoDB. So without any further ado, let us see what's the overview of this project. This project is going to be a, you can say, mini database engine. Basically, it is going to be built on Python, and it is going to simulate some basic functionalities of a NoSQL database, such as data storage using JSON files, CRUD operations such as read, create, read, update, and delete, and query-based search, schema validation, and modular architecture. So the goal of this project is to understand the backend system design fundamentals, including data handling, abstractions, and modular programming. So here is the architecture overview, or you can say the surface level architecture of this program. So this project follows. I'm sorry. Yeah. So this project follows a layered modular architecture, separating the responsibilities into distinct components, such as the user interface, or you can say for now it is you can say command line interface only. Then there is a core layer, which is the database engine, and then there is the operation layer. Of course, the CRUD and the query is going to happen there, and then we have a storage layer which handles the files, and at last there is the JSON files, basically the persistent storage. Now the key design principles are like this: separation of concern. Each module has been a single sign, a single responsibility. Modularity, components are reusable and independent. Scalability, easy to extend with new features like indexing, caching, and other. The now about the maintainability, of course, it's a modular code, and it's also going to be structured, so it is going to be, you know, say, easy for debugging and updates. Now here is the, you can say, the exact project structure we have here. So this JSON-based main database is a project name, and it's going to have some directories which are data, schemas, metadata, source, and readme.md file. So in the data, we gonna have some JSON files or actual records. Then we got the schema, or basically you can say that the JSON that we are going to define the structure of those collections. Now then we have a metadata, you can say .json file. It stores the database related info, and about this, you can say source, it is going to have our core operations and utils, basically all the things that we have discussed in the surface level architecture. Then we go to our config and our main is to connect all the source code, and the config is to define some, you can say, core functionality like path handling and all those stuff. And now the we are going to see about the different modules and the file responsibilities. So main.py is going to be our entry point for of the application. Responsibility, it is going to handle CLI interaction, takes user input called database methods. Then we have config file. It is going to be a central configuration file. It is going to store some file paths, global constants, and environment configurations. Then we got the core layer. In the core layer, we got the database.py file. It is going to be our main database engine, basically the main controller of this whole project. And it is going to have a class called as database, and responsibility is going to be like something, it is going to act as an interface between user and the system, and it is going to route the operations to appropriate modules. Now the key methods it is going to have is something like insert, find, update, and delete. And then we go to the storage.py. Now it is going to handle the find operations. That's all. Now the schema manager, it is going to validate the data structure. That's the main purpose of this, you can say, schema manager, you can say, module. Now we go to the operations layer. Now the operations will have a CRUD layer. CRUD basically to handle the, you can say, create, read, update, and delete logic. Then we got the query.py, which handle the searching and the filtering. Now there is an additional layer which is a utility layer in which we are going to, you can say, keep some common helper functions such as you can say unique ID generation, data formatting, logging helpers, and all those stuff. And then we at last we have a data layer which is going to store the actual record or the actual JSON file. Uh, at last we have schema which defines the structure of the collection. Like as you can see, the example schema here, it is going to have something like, okay, what is the column name and what's its data type in actual. And then we go to the metadata. It basically stores the database level information, like a list of collection schemas and mappings. And here are some feature implemented. JSON-based persistent storage, modular database architecture, CRUD operation, query filtering system, schema validation. Now, for the future enhancement, I'm thinking of, you can say, enhancing it with the indexing for faster search, query language support like MongoDB operators, CLI improvements, logging system, basic transaction support. So at last, to conclude this project demonstrates how a simple JSON file system can be abstracted into a mini database engine, providing the insights into backend architecture, data management, and system design thinking. So with this, we have officially seen all the things that we need for this project. So meet you in the next video in which we are going to actually code all the stuffs that we have been gone through. And I know this is quite, you can say, after some long time that we have connected. It's there is some I will not say any kind of excuses. Of course, I was late. So hope you understand. So with that note, let's meet in the next video with our code. So thank you.